Hey everyone, welcome back to the Vortex. Today, we're going to be doing another easy video because it's still National Novel Writing Month and I'm still writing a book. And it's too much effort to do a full scripted science video. So, we're doing another easy video today. However, it's going to be about black holes, so there's going to be some awesome science in it. Maybe we'll do a full episode on black holes someday. I don't know. Anyway, let's get into answering the internet's most asked questions about black holes. Are black holes real? Yes. Yes, they are. The history of the discovery of black holes is they were first thought up by a physicist named Schwarzschild. In Einstein's theory of general relativity, you can do math and you find out what gravity would be like for a point source, that is mass that is concentrated at a single point, and you find out that there is an event horizon, which is a distance at which light cannot escape, and you find out that at the center, where the mass is all concentrated and the density is infinite, you get a singularity, which means the math gives an infinite number of answers and we have no idea what it means. For a long time, it was thought that black holes could not form. There was something that made them impossible. But then we observed near the center of the Milky Way galaxy at a place called Sagittarius A star that there are a bunch of stars that are orbiting around seemingly nothing really fast. And the only thing that we knew of, theoretically, that could account for that is a supermassive black hole. And then, only a few years ago, we used the Event Horizon Telescope to actually take a light-based picture of the accretion disk around a black hole, the supermassive black hole at the center of the galaxy M87. The Einstein... Why do they have to start vacuuming now? So, yes, we know for sure that black holes exist. We have theoretical evidence, we have indirect evidence, and now we have actual pictures. Are black holes invisible? No, they're not. Light cannot come from black holes, but we can still see them because we can see where light doesn't come from. We see it as the color black. So we can see a patch of pure black where the black hole is. We can also see the accretion disk around the black hole, that is the matter that is being pulled into the black hole. Some of it is orbiting, some of it is being pulled in because it's too close to orbit and there's a lot of friction, and the friction heats it up, which makes it glow. These pictures are actually colored from infrared light, which we can't see. It's a false color image, but if we could detect the visible light, there would also be visible light there. So no, black holes are not invisible. We can see the shadow, the event horizon is within the shadow, and we can see the accretion disk. Are black holes dangerous? Not to us, unless we make them in the lab, and then still probably not. All astrophysical black holes are far away from the solar system. Space is really big. If there are rogue black holes just flying around through the galaxy, chances are likely that they won't hit anything. There are probably many fewer black holes in the galaxy than there are stars, and our solar system is not going to run into any other stars anytime soon, and it is much less likely than that to run into a black hole. So no, black holes are not dangerous to us on Earth, but they could be to like science teams that go out in ships and study them. Are black holes wormholes? Probably not. We'll talk more about this in the wormholes video when we get around to that. Basically, the idea of using black holes for wormholes is that we have to try to make sense of how space works when there's this literal pocket that is like ripped out of space, that is the inside the event horizon of the black hole. And so we do some math tricks and end up with another universe on the other side, but it's more of a math trick than an actual theoretical prediction. The math works, so if you want to do it for science fiction, you're welcome to it, but it's not particularly likely in real life. Are black holes hot? No, in fact, they are very, very, very cold. Everything with a temperature radiates blackbody radiation, and black holes radiate Hawking radiation. You can treat Hawking radiation as if it's blackbody radiation, and that gives the black hole a temperature. Unless you're asking about the accretion disk around a black hole, in which case, yes, it is very hot. It is hot enough to glow. Are black holes dark matter? I realized after shooting this that I neglected to explain what dark matter is. Dark matter is a type of matter that only interacts with gravity and with none of the other forces, as far as we can tell. It doesn't clump together as solid or liquid. It does not attract itself or repel itself. If two dark matter particles are on a collision course with one another, they just pass right through as if the other particle weren't there. And the same is true for a dark matter particle and any other type of particle. Dark matter passes through everything. If you hear scientists or other people saying we don't know what dark matter is, what they're really saying is that we don't know how dark matter fits in with the standard model of particle physics. There are alternative models for what dark matter is, but based on deductive reasoning, we are quite sure that it is non-interacting particles because of observations of the rotation of galaxies and because of the behavior of colliding galaxies. If dark matter were black holes, then there would be more black holes than there are stars, and we would see their lensing effects as they bend the light that passes by them on its way to us, making the stars behind them brighter. We don't see this, which means dark matter is not black holes. Are black holes made of dark matter? This is a different question. The question before asks if dark matter is made of black holes. This question asks if black holes are made of dark matter. The answer is the vast majority of time, no. It's possible because dark matter doesn't collide, it doesn't bounce off. There's nothing preventing dark matter from just all going to the same spot. So if enough dark matter came in at the right velocity in a small enough volume, then it would create a black hole. But we don't know of any instance in which that happened in our universe. And we do know that black holes can form from collapsing stars and colliding neutron stars. There could be some black holes made out of dark matter somewhere in the universe, somewhere in the multiverse. But for any black holes that we could feasibly discover with an infinite amount of technology, the answer would be no. Black holes are not made of dark matter. Are black holes dense? Yes, black holes are dense. If you think of a black hole as being the singularity at the center, then black holes are infinitely dense. In practice, though, we talk about black holes as having their mass evenly distributed within the event horizon, in which case a black hole density is its mass divided by the volume within its event horizon. Which means, funnily enough, the larger the black hole, the smaller its density. The mass of a black hole increases proportionally to the radius, but the volume increases proportionally to the radius cubed. Which means as the radius increases, the mass increases a little, but the volume increases a lot, which makes the density spread out throughout the entire volume contained within the event horizon decrease. Hey, it's me from the future. Just wanted to mention a couple things. First, on Sunday, I did a live presentation on my friend's channel, Heart of Michi, on the topic of how to write believable science in a science fiction story, even if you don't know science very well. Secondly, I've answered another list of questions, and I'll post that video on Patreon later this week or next week. This is totally a marketing strategy and not because I saved all the editing for the last minute and it's still National Novel Writing Month. So if you become a patron of mine, you'll be able to see that video when it's ready. Special thanks to our very first patron, Michael Horst. Thank you so much for your support. If any of you have questions about black holes, type them in the comments and I'll answer them to the best of my ability. Thanks for watching, and I'll see you next time.